Myself, let's fix this for next year. So let's pop to what we have as example 2, because yesterday we played with the Play-Doh and we made the semicircles and we made some equilateral triangles. So let's look at example 2. It says find the volume of the shape with a base bounded by the circle x squared plus y squared equals 4 and cross sections that are equilateral triangles perpendicular to the x-axis. And then I went ahead, even though we developed this yesterday, there's the area formula of an equilateral triangle. A equals square root 3 over 4 s squared. So I'm going to give you a brief head start, and I'd like you to make a sketch of your circle and see if you can make a sketch of the equilateral triangle. What's the radius of this circle? 2. And no one is looking for perfection on your sketches. They're for you. But I find it difficult to do these problems without a sketch. So here's my circle. And I'm going to draw an equilateral triangle. So these are S. But what is the length of S? 2y. Good job. Okay. So S is going to be 2y. So my area is the square root of 3 over 4 times 2y squared. Now I am doing these perpendicular to the x-axis, so that tells me dx. So I need this in terms of x. So this is the square root of 3 over 4 times 4y squared. Oh, so that is just the square root of 3y squared. So then I'm going to go to my equation of my circle, and I just need to solve that for y squared. I don't need to go all the way to y because it's conveniently y squared. So that is going to give me the square root of 3 times 4 minus x squared. Volume is going to be the integral of the area times the thickness of my slices. My slices are, we're trying to get them infinitely smaller to add them up and let calculus do its work. So on the x-axis, what would be my limits of integration? Negative 2 to 2. My area is the square root of 3 times 4 minus x squared dx. Now there is an easy way to do this. This one's definitely calculator. You could use the symmetry feature, but I don't know why you would need to bother because we can just do this on the calculator. Ooh, I see some good answers. You have your calculator. Grab your calculator. Have them out. And I'm going to compute it. I see some good answers. Yeah, that's what I'm getting. Good job. I just want to make sure those, you should be practicing. I got 18.475. Remember to go 3 decimals. All right, let's pop now back to example 1. And let's take a look at the volume of an object with a base bounded by the x-axis, x equals 9, y equals the square root of x, with isosceles right triangle cross sections, and the cross sections are perpendicular to the x-axis with the right angle along the x-axis. A little typo. So let me give you a moment to make a sketch. And let's see if you can get the region. So I'm going to go ahead and start this one. So here's my square root function, and I have the vertical line, x equals 9. So I am talking about this region, and I do want the cross sections perpendicular to the x-axis, so that's dx. Now, this cross section, so I'm trying to take this one, and this is the bottom of it. It says that the cross section, and you could do this to the top or to the bottom, but that the right angle is along your x-axis. So this side and this side are equal because it's isosceles. Yeah.
Would it change anything if it was along the curve? I assume not. It's just indicating that there's the. I assume it wouldn't change anything.
It shouldn't. It should. Yeah, and that's what I meant by you could have drawn it up that way too. Yeah. It does. Yeah. It's just saying the right angle though is along the x-axis.
So basically, the right angle is at the bottom.
Yeah, it is at the bottom here. All right. So what is the side length then? Y. So this is y and this is y. Now, the area of a right triangle is 1/2. You do base times height. Well, this is isosceles. So it's a equals 1/2 y squared. Because I know where I'm headed with this and I've got a volume coming up and I want it in terms of x, you're going to plug in the square root of x squared. So that's just 1/2 x. On this one, let's not use the calculator. Okay, do not touch a calculator, but this time I'm going to pause and I want you to write the volume equation and then evaluate the integral by hand. This one was a simple one. So let's practice. All right, what are the limits of integration? 0 to 9, because you're going along the x-axis, you have 1/2 x dx. So I'm going to increase the power by 1 and divide by that new power. And that's from 0 to 9. So you have 1/4, 9 squared minus 1/4 times 0. Give me thumbs up. How many got 81/4? Got all the way? Awesome. Okay, so now let's find, I think it's example 4. Example 4 says the base of a solid S is the region bounded by the parabola x squared equals 8y and the line y equals 4. Cross sections perpendicular to the x or to the y-axis are isosceles right triangles with the hypotenuse lying in the base. All right, so I'm going to be doing cross sections this way. So I want this to be dy, and I stink it. But this is my right angle because that's my hypotenuse, okay? That's my hypotenuse. So then what is the distance across? Two x. All right. Well, this is an isosceles right triangle. So wouldn't these be 45, 45? So then what would be my side lengths? Yeah, Logan? Okay, so tell me how you got to that. Wouldn't you?
I just I just feel like I remember that.
Yeah.
It's square root 2 times the hypotenuse.
Yeah, exactly. So what I'm doing then in reverse is you could take the hypotenuse divided by square root 2, right? So then that's going to be, I'm going to multiply by square root 2 over square root 2. So I'm getting x square root 2 or square root 2x. I just don't want that to look like the x is under the square root. So then what are going to be my limits of integration? Because I'm on the y-axis, so I'm going to go 0 to 4. But then let's think a moment. The area of a triangle, a right triangle, is 1/2 the base times the height. But that's the x square root 2 times x square root 2. So what's that? X squared. Oh, well, isn't this convenient? All right, I'm going to pause a moment and give you a head start. I heard a correct answer there. So let's look at my volume. If I want this in terms of y, because my thickness is dy, what is x squared equal to? 8y. That was not too bad. So I'm going to go 0 to 4 of 8y dy. So you increase the power by 1 and divide by that new power. So isn't that 4y squared? So that's 4 times 4 squared minus 4 times 0 squared. And I heard somebody say 64. That is correct. Yeah.
For the area, do you get x squared root of 2 times x squared root of 2? Is that, do you rotate it because it doesn't matter the orientation, so that's how you got it?
Right. Because it's the base and the height, it's not the hypotenuse. Yeah.
And so you didn't want to have to, you could have taken the altitude, but that would have been a lot more.
I could, yeah. But I don't want to do that because if you just rotate it, I've got the altitude and the base. Yeah, absolutely. Okay, let's look at example 5, and I'm going to give you a head start and see if you can do this one all on your own. I have equipped you. You are ready to go. The base of a solid S is the region bounded by the circle x squared plus y squared equals 16. Cross sections perpendicular to the x-axis are equilateral triangles. Determine the exact, what does exact tip you off with? Don't use your calculator. Don't use your calculator. Find the exact volume of this solid. So let me give you a 2-3 minutes head start. Let's see. And remember, you don't have to go the whole way to simplify. Okay, you don't need to, I'll show you my final answer, but you can stop once you get rid of any letters. If you need to look back at what the area of an equilateral triangle is, you may do that, but also be able to develop it. All right, and because, well, I'll put an extra step here for you. Because of my symmetry, I can change this to 2 times the integral from 0 to 4. You can literally stop here, okay? If this is any questions on that one? And do you notice that, like, I am specifically pulling that base of whatever my object is and I'm making it parallel and working from there. That is what helps me. Yeah.
Doing this, on the problem, I think yesterday, maybe it was something 0.199, and it had a bunch of nines after that.
Yeah.
So when we round that, should that be something 0.200?
Yes. Yes.
Meaning 2 to 0 to indicate that you rounded it.
Yes. Now, the other thing you can do, what they will accept, is you could go and write 0.199999, and they'll take that. If you go beyond the 3, like go a couple beyond, and they'll take that. If you're a little nervous about how to round it, that's okay too.
So do that unrounded but go past.
Go past it. Yes, go past it. That's okay too. All right, let's look at this one, and then we'll see about our time. I have 3 free response questions that I thought we could look at. In this first one, these are actually, and I didn't put the Play-Doh back, so I have f of x equals 1 over the square root of x, and it says let R be the region in the first quadrant under the graph for x equals 4 to x equals 9. So I'm talking about this region here. Letter A says find the area of this region. So we know how to do this one. To find an area, everywhere I would take a slice, it would be top to bottom. So I'm going to do the area. This is on the x-axis because I would be making slices perpendicular to the x-axis, so the widths are dx. So now you can see a connection. I was trying to lay the foundation when we learned about area between 2 curves. Now this is top minus bottom, but do you understand that's 1 over square root x minus 0, so that's why it's just 1 over square root x. So I'm going to change that to x to the negative 1/2 dx. On this problem, this is a no calculator, so let's not touch the calculator on this one. So go ahead and find the area. Give you a brief head start on me. Go ahead and integrate and evaluate. So I increase the power by 1, divide by that new power. So that's 2 square root 9 minus 2 square root 4. Did you get 2? All right, awesome. Letter B. If the line x equals k divides this region into 2 regions of equal area, what is the value of k? Well, what would be the amount of half of the area? 1, right? So here's what I'm saying. I'm saying that I want an area that if I do 4 up to k of x to the negative 1/2 power, what would that k be so that when I found that area from 1 to k, it's half of the entire area? Well, we found, and so do you see how these are connected? So let me give you a little head start and see if you can do this. And see, and again, don't touch a calculator, but the answer will be, I left it as a fraction. That's okay. And I do want you to stop and think about what I've done. I know half of the area is 1, and I want to know between 4 and 9, somewhere is a kx is k that would give me an area of 1. You could technically do k to 9, right? I could do k to 9. That would also be an acceptable equation. All right, so here I go. That would give me 2x to the 1/2, and I'm evaluating from 4 to k. And then all I'm doing now is solving for k, and this is some real basic algebra too. I'm going to divide by 2 and square. So k would be 25/4. How many of you got there? Okay, all right. It's exciting. This is exciting. We're going to do awesome on the May 9th exam. All right, letter C. Find the volume of the solid whose base is the region R and whose cross sections cut by planes perpendicular to the x-axis are squares. So I'm going to pause a moment and let's see. This is what we've been working on. See if you can do this. Again, don't touch a calculator. You're going to leave your answer exactly. So if I were to draw this, the square is y. So that's y squared, or 1 over the square root of x squared, which is 1 over x. So here's my volume. I'm going to do the integral from 4 to 9 of 1 over x dx. Well, what is the integral of 1 over x dx? Natural log absolute value of x from 4 to 9. Since those numbers, 4 and 9, are positive, I'm allowed to drop the absolute value symbol. So I'm going to get natural log 9 minus natural log 4. That would be acceptable. So is this. All right, questions on that one? Can you give me thumbs up, out? How do you think you would have done on this if this were your free response question? Up, out, or down? All right, good. Do you think you would have gotten at least 4 points? I think so. I think we're doing great. All right, let's do this one, and then we'll see about time about the last free response. Let R be the region enclosed by the graphs. This is a calculator active, so you can have your calculators out. Let R be the region enclosed by the graphs of y equals the natural log of x squared plus 1 and y equals cosine x. You're going to get 1 to 2 points, probably at least 2 points on this one. If I want to find the area, I've got a problem here. I can tell it's top to bottom. I don't think that's our issue, but what's the issue? The intersection point. So that's why we can use a calculator. Check your mode, check your mode, check your mode. Make sure you're in radian mode. Put these in and find those 2 points of intersection. So on a calculator active problem, one of the usage is to find those points of intersections and to look at graphs. Once you find your points of intersection, go ahead and write the integral that would represent the area and calculate the area. Again, in case you didn't hear me before the period started, I put the AP IB schedule. So if you're taking AP Calculus AB, that is on May 9th in the morning. It says 7:35 a.m., but you'll need to, I'm sure you'll get some sort of email where you go and the exact time, but that's the approximate time for ours. But all those are there. Tentatively, I have plotted that our next quiz is going to be, I think, not next week, but a week from Monday. Then we're not going to be able to get the Chapter 8 test in before the AP exam. So when we get back, you'll, from the exam, we'll have 2 days of review and then do that big unit test. Why is it not? Why is it not wanting to write here? Did you get 0.916 and negative 0.916? Yay.
So if we're approximating, if we round it, should we do the one symbol where it's like the approximating symbol instead of the equal? Or does that really matter?
On here, no, I don't think that would matter. All right, for some reason my pen. All right, Logan, why is my pen not working? I've unplugged and oh, I wonder if my.
It might be dead.
It might be dead. Okay, that could be a possibility. All right, let me quit the recording.